Hello all, welcome to the Linux Rootkits for Red Blue Teams course on Pentester Academy. Now in this video, we will look at how we can go about browsing the source code of the Linux kernel. Now, as you can imagine, if you have to do kernel mode programming, and if most of the documentation is really reading the source code, then we have to be very adept and nimble at navigating the source code tree and quickly being able to find what we want. So let's jump right in and try and understand what we are looking at. So I have my VM up and running, and I have one of the interfaces in host only mode. And again, you could use the terminal in here as well. Alternately, I've actually connected over SSH to my VM. Okay. So let's go inside the Linux source code directory. Let's do an ls. And we actually see a bunch of subdirectories in here, right? So let's look at a couple of important ones. Now, inside architecture is really all the architecture specific code depending on which processor family you're talking about. Now this is really where you have the specific code for booting, memory and very early stage process management and whatnot. So we can clearly see we have x86 in here. And we also see we have x86 64. And if you notice, x86 64 just has one directory. It's simply because it does end up sharing a lot of stuff with x86. Now, similarly, you also have ARM and a bunch of other families as well. Now, the next interesting directory is, let's say, the block one. So if you do an ls block, now what this basically contains is the very low level code which actually drives the block device layer. And of course, in our case, we can see .c.o as well, which is the object files which were created because of our compilation. If you had just pulled up the source tree and had not compiled, we would only see C and H files and maybe other directories and make files. Now, crypto contains information about crypto, which is actually being used and applied in the kernel, different algorithms, as you can see. Drivers, of course, as the name clearly suggests, is basically device drivers, and we can actually see that based upon the device type, we have other subdirectories as well. And inside that, we have more directories. So for example, drivers USB, you can clearly see there are more subdirectories, and depending on the class of the driver, you would have generic drivers and whatnot, right? So a lot of stuff in here. Firmware contains actually the firmware which is embedded into the kernel. The FS, as you can see, is basically everything to deal with file systems. After that, you have the include directory. It's a very important directory. So the include directory ends up containing the system header files, right? And we all used include Linux quite a lot already. And there are many other directories inside include which contain system header files. Now after that, you have the init directory. Now the init directory has to do with the starting up of the kernel itself. Then we have the IPC directory. So this actually contains the sys5 IPC mechanisms which are available. Then we have the actual kernel directory, right? So this is really where all your kernel code is actually put in. Then we have lib for libraries which are supporting us. Then you have the directory. This is actually for all the memory management stuff in here. Then you have the net directory, and again, as you probably already guessed it, this contains all different kind of communication network related code in there. You can clearly see wireless, MAC 802.11, etc. Right? Now samples directory actually contains some amount of sample code. So we have kprobes in there, we have trimers, trace events, seccomp, etc. So this is really nothing but code from where we can look and learn. Then you have scripts. These are all scripts which actually help with the compilation, etc. And of course you have security. So this contains security related code, SE Linux, and all of that stuff. Then you have sound, as the name evidently kind of tells you. This relates to your sound device drivers, etc. And after that, we have the tools directory. These are all really supporting user space tools. And then we have the user directory. This currently I think contains pretty much stuff to do with init ramfs. So it's an in-between RAM-based file system, which the kernel initially mounts and uses utilities from before mounting the entire file system. And then you have the virt, which is really virtualization. You can clearly see KVM show up in here, right? So as you can see, there is a ton of code in here. And of course, this is a very, very high level view that I've actually given you. There's a lot of stuff going on in there as well. Now, if you were to actually look at the sheer number of C and H files, actually see it's a massive number of files, right? It's probably going to take us a couple of minutes just to be able to look at the number of files, right? So if we were to do a word count -L, don't know how much time this is going to take. Okay, so there are almost like 78,484 files we found out. It's a lot of files, and I can only imagine how much of code is actually in there, right? Easily a couple of million lines. So now when we are actually programming more advanced kernel modules to deal with rootkits and other things, it is important for us to be able to search and navigate this code effectively. And this is really where we will require some kind of source code navigation tools. Just isn't possible to do, manual grep cat and all of that, right? It would just take us too much time. Now, this is where kernel developers use a bunch of source code browsers. The older one, LXR, or the Linux cross-reference browser, was one of the more popular ones. Then you have GNU Global. You can even use cscope, ctags, and there is also a newer one, Elixir, from the Bootlin guys, who've done a lot of stuff in embedded systems. And they even have a web version where they've already cross-referenced the kernel source code for multiple versions of the kernel. So if I were to just take you to the web pages, here is LXR. The last release, of course, was March 2018. And again, LXR and all of these source code browsers, especially the ones which give you a web interface and do a lot of cross correlation, keep in mind, A, they're going to take a reasonable amount of time to create everything. B, also a lot of space to host everything. So you're looking at a couple of gigabytes worth of space. Then you have, as I said, Elixir, and what the Bootlin guys have done, which is what I really like using, is based on the version of the kernel, as you can see here, all the way right from the 2.6 kernel. They have gone ahead and cross-referenced all the source code and made it available on their website. Now you can download and do the same thing with Elixir, but as I said, it's just going to take you a lot of time and space. Unless you're working in a totally offline environment, my suggestion is to use Bootlin's Elixir cross-referencer tool. Now, apart from that, you also have GNU Global. This is very, very good, more advanced tool, and does source code tagging in a very comprehensive way. I've used it, like it. There's also Open Grok. Again, a lot of people like it. Now, in this class, we are going to be using Bootlin's Elixir cross-referencer, as well as cscope and ctags, which are command line browsers. So let's jump right in. Now, if you wanted to create the files required for cscope to run, you're going to do a make cscope. And this is inside our kernel directory where we already have the compiled kernel. So I'm going to do a make cscope. This does take some time. Now, while this is working, let's actually look at Elixir's Bootlin. So our version is 4.16.7. So I'm going to click on 4.16 here, and I can see 4.16.7 is right here. Click on that. So that becomes now the selected version. Now, if you wanted to go ahead and search, let's say, for anything. So I'm going to put in a struct I'm searching for called task_struct. Hit an enter, search for it. It immediately tells me that this seems to be defined in 2 places and referenced in almost 1400 files. So if I click on the first one, Linux shed, which is schedule.h, it automatically takes me to the place where task_struct has been defined. Fantastic. So that now I can look at this structure. So this is a very important structure which we'll begin looking at in the next couple of videos. And for any process which is actually running, this structure is actually filled up with the information of the running process, right? Now you're here and now you're curious, well, what is this thread info? You could actually click on it right here, and this will actually show you places where thread info has been defined. As you can see, right now we are getting for every single architecture, because a lot of times the structures are architecture dependent, right? So we can clearly see a lot of them. Here is the one for x86. Click on that, and we can see that here is how the structure is defined, right? So it is very, very easy to click on any symbol and basically go ahead and figure out what this is about. So we can again see that this seems to be architecture specific. And oh, of course, this is just a hash defined, so there isn't going to be any other place where it's defined, right? Only in one place. Okay, so as you can see, the make cscope is taking a little bit of time, and this is expected because cscope is kind of trying to go ahead, look at all the source code and create all of those correlations so that when you search for stuff, you can actually find it easily. So as I said, my recommendation is try to use Bootlin. I'm going to be using a mix of Bootlin and cscope and ctags. And the only reason I use cscope and ctags is I'm very used to it. That's when I was a student almost 18 years back when I started, my engineering. At that time, I started with using Vim, cscope, and ctags for all my projects, and that just stuck with me. So there isn't really any kind of superior way. Anything which gets the job done within a reasonable amount of time is good enough. So you can use any editor you like. You can use Bootlin, or you can follow along using a combination of Vim, cscope, and ctags, which I'm going to be doing. Okay. Let me pause this video while cscope finishes. Okay, so cscope completed. And if we do an ls, we actually see a bunch of files which have been prepended with the word cscope, right? So these are files which actually the cscope utility will use. Again, one of the things I may have forgotten is to show you the installation. I think we did it. Cscope and ctags, if I recall. but just to be sure, right? So if you haven't already, you can run this command. Now, if you want to use cscope, one of the things we are going to do is just a cscope-d, and this text-based interface opens up, and you can see you have a bunch of options here, finding this C symbol, finding this global definition. So let's say if you want to do the same thing, you can put in task_struct in here, hit an enter, and this will show you a lot of places where it seemingly has found that task_struct has been defined. Now, if you notice, it isn't doing a great job like Bootlin did, giving us a lot of matches. And if you go down a bit, we'll actually find that right over here, we have the actual definition under shed.h. So I can type in the C character here. If I type in C, I automatically get taken here. And this uses the default editor, which is VI or Vim in my case. So I type in C, and if you notice, I immediately get taken to the file and to the place where this structure is defined. Right, and now I can look at it. And once I'm done, I can actually exit the editor. And again, you need to know Vim commands in order to exit. So if you want to use cscope, figure out how to use Vim. Rest of it should be pretty easy. Now, if you wanted to look at, let's say, all possible places where this symbol is, and find the C symbol, and you'll actually see all of them. And again, there are many, many more. You could actually click on any, or rather, put in the number for any one of them, and you will be able to see it. Great. Now, one of the other things I like to use along with cscope is C tags, and what that allows me to do is basically cross correlate. So I'm going to do a make tags, and again, this is probably going to take a couple of minutes, so I'm going to pause the video here. Okay, so the tags have been created as well. And if you do an ls, we can actually see the tags file here. And this actually is a pretty big file. As you can see, it's almost 610 megabytes. So what we are going to do now is let's actually open up cscope once again. Oops. And again, search for task_struct. So here is the definition. Now, where C tags actually comes in handy is, let's say we are navigating this structure, and then as we are moving through this, we look at another structure, let's say struct ll list or any structure, variable, anything which is defined, and we want to know what this is, right? So what we have to do is hit a control close bracket symbol, and when we do that, C tags actually goes ahead and figures out where this is defined and takes us there. So if I do a control close bracket, if you notice, it takes us to a new file, which is linux lllist.h. It's probably part of the linked list definition. And you would see here that that structure is defined right here, right? And we can go ahead and do this pretty much for any other part of the code as well. I mean, in some cases it's not able to find, and that's where tools like Bootlin are much more better. So let's say here's a union RCU special. So I do a control close bracket, takes me to where the union is defined, right? So this is very, very handy because, if you are like me, more of a command line guy, you don't like switching between, screens, tabs, moving the mouse and putting that into a search bar, etc. in a web browser. You really want to have the flexibility of never taking your hands off the keyboard, right? And if you're one of those people, hey, cscope and C tags is a great combination for most of the searching. Great. So this is all I had in mind for this video. The whole idea was to get you kind of a little bit acclimated with the different source code browsing tools available and what we will use in later videos. As I mentioned, if you're a beginner to this, the online website Elixir Bootlin is the best place. If you really want to kind of go ahead and make sure that you're going to be programming quite a lot and you want to be fast, cscope, ctags is definitely better in that case. So that's all I have in mind for this video. If you're enjoying your time at Pentester Academy, please do recommend us to your friends and colleagues in the InfoSec community. Thank you.